afternoon, everybody, and welcome to Zahn Academy. Today's webinar is Going in the Lab with Marrano Dental Arts and Flexcera Smile Ultra Plus. Today's presenter is Dan Marrano. Dan is a CDT and the owner of Marrano Dental Arts. So today there will be no live Q&A. I just want to let everybody know that, please, if you have any questions for Dan, just send them in an email to zahndental@henryschein.com and we'll get them over to him and get the responses over to you. So I want to thank you, Dan, so much for joining us today on Zahn Academy. And I'm going to turn this over to Dan. Everybody enjoy the presentation.
Hi, Fran. Thank you for the introduction and inviting me today. I look forward to sharing information and experience that have benefited our lab. Full disclosure, I'm not Jack Marrano. I'm Jack's younger brother. Jack has been instrumental in my career with advanced training, techniques, material science, and selection, including the materials we're talking about today. Now, I think we've put together an informative presentation that you'll enjoy. Let's begin. I do not know why it's not going next.
That's so strange because we had it.
There we go. Should we just go now? It's working now.
Yeah, sure.
Okay. Today we're going to talk about Flexcera Base Ultra Plus and Smile Ultra Plus. These are two materials that we use in our lab on a regular basis. The equipment validated for Flexcera is, of course, the Einstein carbon was recently added, and the Asiga. Just about a month ago, I think Asiga was added. So any printers from Desktop Health, Carbon, and Asiga are validated to print the resin currently. My introduction to Flexcera, my good friend Dr. Mike invited me out to an implant lecture. It was a few years back, and at the time, I was not familiar with the benefits of Flexcera Smile. During the course, they had planned to do photogrammetry same-day provisional. His assistant had an old temp that I wanted to show them how to open the abrasures and make it nice, kind of do like a green state finishing with it. And I cut into it with a diamond disc, and I still remember the feeling and how strong it was. At the time, I was using a printable tooth resin that was similar to like typical chairside Luxatemp. It wasn't real hard. We're doing hybrid tries, direct to multi with printed temp resins. And we always had to tell the doctor, please don't over torque these screws because it would blow right through the material. And Flexcera Smile was like nothing I had used at that time. So I was very excited for it. But I was a little slightly cautious. I was behind the early adopters. I didn't jump in fully immediately. I took my time. And one of the reasons is, as a small lab, I found the cost of testing materials is challenging with these new materials. You know, back in the day, we'd get a zirconia disc and maybe be $125. And now these tooth resins can be upwards of $1,500 for a kilogram, not even a liter. So it's challenging to make that kind of investment in something that you're really not sure about. So we wanted to have something that had a little bit of time and performance. And as we got into it a little bit more, we needed a model printer. So we had got the D4K Pro. And it allowed us to kind of dip our toes in the Flexcera. We didn't have to make a full commitment. But as we started seeing more of the benefits of using Flexcera, we then purchased an Einstein. And we dove right in at that time. With our Einstein, we see fast, accurate, minimal print lines, and it's just a great printer. We love our Einstein. And using Flexcera for these indications have worked well in our lab, and this is how we've incorporated it in our lab. If there's preferences, of course, you know, we have some doctors that maybe like, you know, insist on having something milled. Then we of course do it. But for us, we use it for provisionals, prototypes, and we started thinking about how we could use it more because we were just a fixed lab. So we would get asked for like implant conversion dentures, immediate dentures, copy dentures, flippers. And these were things that, uh, we could incorporate easily without, taking a full dive into going into a removable lab. And implant conversion dentures started becoming more popular and being asked for us because we were going to do the final, and they wanted us to kind of set it up similarly to the fixed restoration. So the benefits of Flexcera and 3D printing, if you're not familiar with benefits for 3D printing, most importantly, it is cost effective. Here are some price comparisons between printing and milling. It's a substantial savings. And, I look at that as savings that I can reinvest into the lab. Every time we turn around, it seems like we have a new license or a dongle fee. Or now you can use the materials savings to reinvest into your software, equipment, more employees, to improve your products and offerings to your clients. So we can now use the savings from printing to better our lab and the things we can offer from it. Speed and efficiency are one of the biggest benefits of printing that I find. If we look here on the side, this is a bridge nested in milling, and it took 2 hours and 11 minutes to mill that bridge. And at the same time, that one bridge only took 34 minutes in the Einstein. It's incredibly fast. And if we look at the efficiency side of it, we can mill three of those same bridges in 6 hours and 9 minutes. Or if we can fill them all on the platform, like this picture here on the Einstein, we put 14 bridges, and it still just took 34 minutes. The amount of cases we put on a printer doesn't necessarily affect the amount of time it takes. It's the height. So unlike milling, we can get a lot more out of each print, and a lot more out of the resin as well. So it took one whole puck to mill 3 bridges, and a lot less material and waste in printing those 14 bridges. If we look at it in terms of a denture, one set of teeth milled took 2 hours and 4 minutes, and the denture base milled took 3 hours and 35 minutes. And if we look at the printing of it, we have 8 sets of teeth in 27 minutes and 8 denture bases in an hour, 33 minutes. So in 2 hours, you could have 8 dentures. And in an amount of time, by the time that denture is done milling, you could probably have those all assembled and fused together and ready to be polished. It's much more efficient, much more cost effective to print these versus milling. And I look at it as an opportunity gain in printing. So if we look at it in comparison, you can mill a prototype in 2 hours and 11 minutes. And that prototype just gets in the mouth for 2 seconds. They check occlusion and aesthetics, and it goes back. And it took you all that time in milling. And you could use that mill to mill 6 or 8 zirconia crowns, depending how fast your mill is. And that's a lot more financial gain for the lab to be using your mill to mill zirconia. And if we look at it in terms of the denture, that denture took nearly 6 hours to mill. And at that same time, I'm sure I can mill a full arch zirconia implant bridge and another 5 single zirconia crowns on it. So we're talking about $300 or $400 for a denture versus, $4,000 in zirconia. So you can use your mill then to do the much more profitable materials. So I asked myself, can you really afford not to print? And for us in our lab, I say no. Again, fit. Everything off the Einstein and with Flexcera is fit. How many people have had temporaries where you get this kind of stuff from burr deflection, from milled PMMA? You got a screw that doesn't go down the hole, or it doesn't fit on the analog all the way. These are problems that you have with milling. And the details and precision of printing far exceeds milling. This is zirconia, example of zirconia that I had. And being enlarged, 20%, 23%, the burrs get in there even more details. And even so, you can see the detail loss between that and the printing. The case on the left there, you completely lost the diastema. The case on the right, the embrasures are completely closed off. So it looks much better. So then you save your time in having to post processes, kind of green state finish them with a disc and get them so they look presentable when they put them in the mouth. You don't have to do that anymore, much less manpower afterwards in finishing these cases. And that's a huge benefit to us. Again, being a smaller lab, when it comes off, we're removing some of the support nubs, polishing or glazing it. Maybe we put some OptiGlaze on it and sending it out for trying. The low limitations of printing is you're not restricted by the milling parameters that we've always been restricted by. You're not restricted by 98.5 millimeters or 20 or 25 millimeter thickness. You're not restricted by the mill capabilities or the angles, 30, 35 degree milling. And you're not restricted by tooling. A lot of these all-on-X cases and stuff like this that we do today, tooling becomes a big part of it in CAM. When we load these in the printer, we just load them and hit some supports and play, and away they go. It's really great in how easy it works. And when we look at that denture that we milled, when we put it in there, it actually gave me an offset error. So it actually shrank the offset around the perimeter of the denture. I didn't actually bother milling this to see the result. But I'm sure around the perimeter we would have had some loss of detail because the burr can get in there. And then when we think about the flange, there's almost no way. I milled a couple dentures early on because I was asked to, and I just constantly the flange is getting in there with the undercuts, and even despite coming in this crazy angle, it still did not mill. It still left all the some residual material inside there. So, what do you do with that? And if it's a fully digital case, you don't even know that's there. Maybe you don't even notice it, and you send it out and they go to put it in, it doesn't fit. So that's a huge disadvantage of milling these versus printing. When we talked about the benefits of Flexcera Ultra, here are some benefits that I feel at our lab is benefit having using it. It's the longevity, the strength, the quality, the speed, the shading, the ease of use, absorption, and polishability. And when we look into these individually, Flexcera is time tested. It's over 2 years old, 2.5 years old almost now. So it's been on the market. And, when we think about that, and we think a lot of resins are coming out on a regular basis, I wondered whether it still holds up, right? So in terms of strength and durability, and printing speed and quality is certainly there. Still, you're at 30 minutes, maybe less if you're just denture teeth. And the quality of prints are great on all the printers. Every printer, Carbon, Asiga, and Einstein are fantastic printers. So we started looking a little bit further into the strength and durability. And many of you, and I'd say probably in the last year, we started seeing pictures like this and videos like this coming up of people trying to break the newer materials. And I thought, I don't know if I've ever really seen that of like Flexcera Ultra. So we took our demo bridge and we took it to the test. And we tried to wishbone it, and we couldn't break it. So we took it a step further, and we set up this contraption. We put a scale in the ceiling and printed all our demo bridge in all kinds of different materials, every material we possibly test, and pitted them against each other. We also tested many of the common and potential issues we see, either it's happened to us or read online, of post-processing. over curing, over soaking in alcohol, and we'll discuss it a little bit later. Um, and we just hooked some fishing line on it and pulled it. Now, obviously, we don't chew this way, but it just gave us a comparison in strength of Flexcera. We were very pleased to see that Flexcera Smile Ultra holds up with many of the modern materials. And it was fun in the lab to get away from doing the average everyday work too and testing those. The shading of Flexcera is very nice. It's pretty accurate shades, and they don't shift during post-processing. So, this was a case in one of our tests again, where we intentionally tried to overcure cases to see different materials and what would happen. And this is another resin that's not Flexcera, that was printed in B1, and it was a great B1 until we overcured it, and then it turned yellow like this. Ease of use, we have low print failure, very few print failures. In fact, I actually couldn't tell you the last time we had a print failure on our Einstein. The fast prints, straightforward, precise, and accurate. The nesting software is fantastic in all the printers that it's validated for. Easy cleaning and post-processing. The supports are very thin. We just pull them off, and the post-processing and the wash and the curing is very easy. Bath 1, bath 2, 5 minutes, 2 minutes. So it's very nice and easy and straightforward. And we know when it comes out too, it's clean. We don't have to worry about getting any extra residual with a microbrush or anything like that. When we talk about the absorption, I don't know if this is talked about enough. I think it is actually pretty important, and it does not color shift intraorally. Of course, you have, staining that happens on any temporary material. But this situation actually happened to us last summer, and I call it Orange Crush. We did a 3-unit bridge, a temporary for a doctor, and just a few weeks later, we got a call. The patient was irate that her bridge turned orange. She was drinking an Orange Crush, and her bridge turned orange. So we liked the testing, so we ran across the street and grabbed an Orange Crush soda and brought it back and started soaking all our bridges of the different materials. And we did notice that some of them were turning orange. Flexcera had no color change whatsoever. I couldn't even tell it was in there. Later on, we did find out that Orange Crush was not a soda that she was drinking, but it was, an adult drink later. I still have not had an Orange Crush, but I'm looking forward to it. And you may be seeing a picture like this from time to time online as well. This is not Flexcera. This poor guy got his new hybrid and from a doctor's office, and I think it was like a week later, it turned out like this. That's pretty bummer. Polishability. It shines up incredibly well, incredibly easy. It's not a lot of effort to get these to look good. And that is nice when it comes to getting them out the door, finishing them, and making sure they look nice without having to put any clear coats or anything like that on them. When we look at IFUs, we like to follow them as a lab. We're required to follow the validated processing of the materials. So we also found you get better success. So when it comes to the rolling, though, as of last month, those who don't have a roller will find that it's nice. They no longer have to roll it. So they don't need it, or they can retire their hot dog rollers that they've had stashed away. All you have to do is shake it for 5 minutes. We're going to probably still roll it because you get some air bubbles in the resin when you shake it. So we'll probably just still roll it to make sure it's got a good mix, before we print. But you don't have to roll it anymore. The cleaning and curing instructions are incredibly important to follow with any resin that we found. Avoid excess over curing. Flexcera, you won't notice in terms of like the color change or anything like that you over cured it, but it can become a little bit brittle in over curing. Our testing, we double cured, maybe a little bit unrealistic because, maybe you forget to, do an extra 3,000 flash, but it can become brittle as you overcure. Many resins being much more brittle than Flexcera, but you won't really notice it. So just keep track of, you're flipping in the auto flash. Here is the most important one that we found is to avoid over soaking in isopropyl alcohol. In that test where we pulled on the bridge, we lost as much as 40% by doing a double wash. So you walk away, you don't set a timer. If you got one of those, form washes or whatever you're using, just make sure you set a timer, use your phone, get over there 5 minutes, get it out, get it into the next one and swap it again. And then try it as the instructions state. That way you're not over soaking it. We found it's incredibly important, and we think that's probably where a lot of loss of strength can be when we talk about these modern printed materials. One of the tips I found is to provide the denture instructions with your cases. We started doing this just to make sure they're being cared for properly. These are QR codes. There's a disinfection and sterilization. We don't steam them. I just take a toothbrush now after I'm done pumicing and polishing it, and just clean it off. And then the care instructions for the patient as well, are a little bit different than typical dentures. So I think it's important to send these along. So what are we offering here? And this is one material has brought all these extra offerings that, maybe were time consuming or things that, weren't really profitable before, that now we can suddenly make a little bit extra money, save a little bit of human time and processing and working with them, and machining time as well. So we do tooth-borne temps, shell temps, snap-on try-ins, implant temps with the tie base. We do prototypes and provisionals, verifications, immediate dentures, conversion dentures, final dentures, copy dentures, flippers. I mean, that's a great amount of products that you can now offer your customers just with one material. So when we do our prototypes and provisionals, we do direct to multi-unit. This saves time and money and extra components and resources cementing each arch. This allows us to keep the cost down for us and our clients, which is a great benefit. Everybody appreciates that. And this is our demo bridge again. And so even if you don't want to do your prototype, or if you want your milled temporary in milled material instead, or say you're going to zirconia, we always definitely do our prototypes and our try-ins in printed material, because they're going in, they're coming out, and you don't have to cement them and then uncement the tie bases and then re-cement them in another one if you have to send back another try-in. It's very easy and very cost effective on both ends. So if we look from, on a 3-shape side here, if we're going to go to and from a tie base from a direct to multi-unit perspective, you can, and if you're going from provisional to final or prototype and try-in, this is an easy way to do this. It's not like we're doing the case twice. So when we get designing our case, whether we started with tie base, or in this case, we did not start with the tie base. We started with the direct prototype. When we get to the end in the finalized step, before it puts all the screw holes in assembly, we go to additional scans and we save it. And the reason we save it, as many as you do know, if you go in and try to change this tie base afterwards, 3-shape might get angry on you and mess up your design. So we save it here, and then just call it, wax bridge or bridge prototype, whatever you want. And then save it as an STL, and then open up a new order after you finish that case and create a wax up. Now, the implant positions need to be exactly the same. The implant tooth numbers need to be exactly the same. And you can bring in, it has to be a model. It can't be a digital impression this time. So you need to import the NB preparation scan from the original design and that'll bring your implant positions in. And then you import the saved design as your wax up. And then you walk it through a wax up, and now we went from no tie base to tie base. So now we have tie base ready to go to zirconia or your temporary, if that's what you need to do. It's a great advantage, an easy way, a quick and effective way, rather than, I don't know, maybe that took not even 10 minutes probably. And it would take you much longer to cement a double set of tie bases. And then if you have to take them out later. So it's definitely a benefit to us and the office and everybody all around in cost and time. Verifications. This is one that we started using Flexcera for because we started seeing a lot of this, broken jigs coming back. And I hate verifications. Doctors hate verifications. Nothing's worse than seeing this come back with our approved prototype to go to final. All we have to do is copy it, but the jig is broken. So this was a jig that actually came back and was broken, just like this. Could have been luted together better. I get it, but we were seeing them even when they were luted well, they would break it now. UPS does not take your jigs, take care of your jigs very well. So they're easy to work with, and here's a jig too that was luted together this way. And this was actually a zirconia jig. It went to final. It didn't fit. The model that it's sitting on is the final model. And then I told him to cut and relute the jig, and this is what it came back. So that case never was passed at the beginning with. It never was going to fit. There was no chance of that going in. And it just, these jigs, these old style jigs were just a little bit difficult to work with. So I saw Dr. Blatz post this on Instagram, and this was his new style verification jig. And the top here, he has a zirconia, old chunk of zirconia that he said he was using, or I believe that was a titanium bar or some kind of castable that they were then using, and kind of doing the opposite. Instead of cutting in between them, they're filling the space around in a hole. So I like this very much, but I wanted a little bit easier way to go about it than getting a big chunk, and we're pretty much metal-free lab, so we didn't have any spare, bars or anything like that. So I thought, well, how about Flexcera? Flexcera is very durable. So when I go into 3Shape, they're actually very easy to make. I just create a bar order, and in this case, I just pulled the MB preparation preparation file from my design again. And I created the order and I imported that. And when I got to the end and I got to the assembly, I just unchecked use screw hole. Some libraries have this. You'll be familiar with it, ones that do and don't. But in this one, I was able to uncheck it. And then after that, I'm able to put a whole bunch of parametric shapes and holes in top of the bar. And then this is what you get. So I get a nice, strong, durable bar with a bunch of holes in it for the doctor to fit. So he screws in his tie bases, or these are temp cylinders, multi-unit temp cylinders. And he lutes them all together, just like that. And we've seen far greater success in doing it this way in accuracy, and to date, we still don't have one broken. So this is a great benefit that you don't really think of maybe in using the material for. And again, this jig did not take very long at all. Denture conversions, it's a value-added service that we can offer our clients, and it's one of these things of low-hanging fruit, right? We're already accustomed to maybe designing hybrids and stuff like that now. And if you have 3Shape, you probably have a denture module where you get CAD points to design them. And here's what we can do when we do a denture conversion. So this was a denture this one was not made by me, but this patient loved this denture, and it was time to go to final. They had dialed this thing in, and they did not want to change it at one bit. Now, the only thing, when you're designing denture conversions, it's nice if you're going to do the final, is that you can keep your fixed standards in mind and design them with that. Maybe you don't have as big of a flange, and most of our hybrids don't have second molars, so we don't put them on our denture conversions. And if you're adding a molar, nobody usually complains. But if you're taking one off, maybe you have to have that conversation with the patient then. So when we do our denture conversions, we don't put second molars on our dentures. So if we want to take this denture and turn it into a fixed temp to go to zirconia down the road, these are the 3 scans that the doctor took. He took an intraoral scan with the desk scan bodies. He took a scan with the denture, the converted denture in place, and then he scanned the converted denture 360 degrees. Remember, she wanted 0 changes of this. So then we made a verification, and we made a verification model, and we scanned that, and we aligned that scan body to his scan body scan, and then we aligned his scan, 360 scan of his converted denture to the tissue scan, and then we got the exact duplicate for a try-in to go to final. This was just a quick try-in because she already had the conversion. So it was just a quick try-in to make sure that we nailed and everything that she wanted. And it was a very easy way to go from a converted denture to a final zirconia with just one step in between. So when we think of complete dentures, we just started working with a doctor recently, and his statement was, "I'm impressed when it comes to digital dentures." He didn't know what to expect. A lot of times we think of the old materials, or you hear horror stories. And this is just one that I did, real quickly, just for this presentation, just to see and show how easy it is to polish it. And maybe even got a little carried away and over polished it. But, that's how it was actually pretty simple to polish the material and get a good result. And the teeth, this is Flexcera Ultra Base and Flexcera Ultra Smile teeth. The teeth look very good. They're very aesthetic. And you have a ton of libraries that you can use now in 3Shape to make a nice case like this. Flippers. When we started this, we started talking about removables and stuff like that. And we don't do any removables. And then we were asked to do a flipper a couple weeks after. And I thought the patient had a surgery, so they had to get this done before the surgery. Their other lab couldn't do it, so they asked us because we had to rush the crown to them anyways. And it was a service that we added that benefited the office and the patient, and another low-hanging fruit. Again, if you have 3Shape, you have the removable option. You can get this flipper done pretty quickly and easily. They dropped in, they loved it. Are we going to be in the flipper business going forward? I'm not sure, but it is something you can offer that didn't take a lot of extra effort, because we have all the tools and the materials available to us just by having 3Shape and Flexcera in our lab. So when we think of some printing tips I have for you is add extra supports along the incisal edges. We do a lot of cases where our doctors print their own, and we often see, edges failed when they put the try-ins in and stuff like that. And, it actually burned me one time, is because the distal edges of their try-in failed. And when we went to zirconia, obviously they didn't fail, and they milled, and she hated 8 and 9 distal edges. We ended up redoing it. She hated it that much. It was just easier for us. There was some other stuff that had changed because the printing didn't really match our zirconia. So you don't want those failed edges, and that's the most important thing that stands out when you look at a case, is the failed edges. So add some extra supports. They're really thin, so it's not that big of a deal to get them off. And our large temps, we let them rest between flipping during curing in the auto flash, the 3000 side. Don't be rushing to flip it real quick, and because there's a good chance it can warp. And prints warp, right? And I saw this topic not too long ago when it comes to printing, and it was like an anti-printing. And I was like, well, of course it works. Like, no big deal, though, right? We know how to handle these things as a lab. We take care of our materials, no different than we take care of any of our other materials. Like, you can have issues with any material that you're using in the lab, but we're trained to properly deal with them. So why would you support it? You support your dentures. But if we just look at this, is the simple L cube, and this is before curing, and then after curing, we get a very accurate controlled shrinkage. And the shrinkage is like 150 microns. And when you think about that on a larger scale, that would be pretty substantial. But what else do we use in the lab that has controlled accurate shrinkage? It's zirconia. So when you think about doing a large bridge in zirconia, most of us would put a support structure on it. We wouldn't think of doing a zirconia bridge without it. So why is this really any different? So if we take care of our materials, they'll take care of us, and we'll have an accurate, predictable material to go out. So when we do a lot of some of our bridges, sometimes we will put the cross support bars, just like our dentures, on them to make sure they don't warp. Generally not a problem if you're not in a rush, and you just let it, don't overheat it, and take care of it during the auto flash curing. It's not really a problem. But if you do find it's a problem, here's a way that you can also help prevent them from warping and keeping that cross arch stability and accuracy. So some more printing tips as we look at it. Open the embrasures in your designs in the midline. Someone recently recommended me that we actually split the denture teeth into half, right down the midline, into half and half. And that worked out really well. That was the denture that I made there. It's a demo. Just so you don't have to sit there and maybe open up the embrasures, but definitely open them up a little bit more, or keep them open in your design. If they get closed off, use a disc and open them up, or design them so that they stay open after printing. And again, this is a big advantage of milling versus printing. There was a shade recently that we didn't have for printing, so I had to mill it, and then I spent 20 minutes grinding and opening up all the embrasures, and that's just time I don't want to have to spend. When it comes off the machines, we want the machines to do as much work as possible, and the mill is just limited in being able to open that up. So when you're designing, you have to now rethink designing for printing versus milling. And back when I visited Dr. Mike's office, this particular bridge you were showing me actually had a hole, like a black triangle in the gingival embrasure, because it was designed that way. It was before I was designing with him. And a mill, I didn't think much of it, because a mill wouldn't get in there, right? We wouldn't have to worry about it milling that out. Even at 5-axis, it likely wouldn't get into that small hole. And so when we design cases, we have to think about there's no drill compensation in printing, and fully fill our embrasures if we're doing bridges. So think about that as you're designing any of your cases. So it's kind of the opposite. So the facial embrasures we leave open, the lingual embrasures we close up to make sure we just add a little extra material in there for strength. We always had it with milling, but now we actually have to design it that way with printing. And predict milling versus printing. And don't get yourself in a pickle. And this is something that happened to me just last week, and I had to put it in here. Again, there's really no limitations in printing. So we had a case that had a full arch case that had a temporary in. And we didn't angle the screw holes because we were working on stuff like that. So we had a screw going through the facial, and the doctor just wanted me to quickly get him a try-in with the angled screw holes. So this was my design, and you can see I couldn't get it lingual far enough, so I had to put it through the tissue to get it out of the facial of the tooth. Well, it became incredibly difficult to mill that. Luckily, I have hyperdent, and with the Roland 52, I had to use the C clamp and the 90-degree milling to actually get that screw hole milled, because I think it was about 45 degrees or something like that. And it was very challenging, but it was perfect and it was clean when it was all said and done. But think about those things in either size or angles that might get you in trouble later. Now, there's other ways we can get out of these things. Maybe it would have been a bar. You probably would have been fine with that. But definitely think about the differences in milling and printing when you're designing and manufacturing. And I wanted to thank you. It was a pleasure presenting Flexcera Ultra Smile and Ultra Base to you today. We've found great benefits to our lab using both in cost effectiveness and efficiency. I hope you can take some time and implement some of this into your lab. Thank you.
Thank you, Dan, so much for allowing all of us to go into your lab and hear everything that you had going on with Flexcera Smile Ultra Plus. We really appreciate your insight. And we just thank you. We thank you for taking the time to spend with us. I want to let everybody know that, again, we're not taking any live questions today with Dan. You can go to our you can go and email us at zahndental@henryschein.com, and we'll get those questions over to Dan and then get the answers over to you. I want to tell you a little bit about what's upcoming on Zahn Academy. Tomorrow, which is June 20th, we have John Madden joining us. And he'll be discussing the Bago material Trinique and how he prints permanent bridges with those. So you don't want to miss that. That's tomorrow, 2 p.m. Eastern, and you can go right on and register for that right after we get off today. We'd love to have you join us. And then on 6/26, we're going to be getting acquainted with the Dental Direct Zirconia line. You'll hear all about its strength, its beauty, and lifelike qualities. This is one that you definitely don't want to miss either. Zahn is coming to a city near you with our road shows on everything 3D printing, along with 3Shape design classes that you can take attached to some of those road shows. So we'd love to have you join us for a day of learning. And please go to Zahn Academy to see where we're headed and join us. Register. We'd love to have you. Again, thank you so much. We really appreciate you taking the time to be with us, to all of our attendees, and a special thank you to Dan again.
Thank you. You're welcome.
Have a great day, everybody, and we'll see you tomorrow here on Zahn Academy.